In this video, we're just going to do a couple of review topics from this chapter. We're going to and even an older review topic. So here we've got 2 to the n over n to the n. When I see powers or exponents, and I usually begin to think automatically of the ratio test. So remember, the ratio test says if I take the term I'm on, the nth term, and I put the next term on the top, what I'm looking for is a limit less than 1. Because I should be setting up a situation where each successive term is smaller than the term I'm on, so the next term should be smaller than this term, therefore giving a ratio or a quotient of less than 1. Okay. Now, I'm actually evaluating a limit of this, right? Let me maybe, for simplification's sake, maybe just right away put n to the n on top, 2 to the n on the bottom. Now, I like to kind of pair these things up and do some simplifying. You'll see here that I have n number of 2's multiplied together. Here I have n plus 1 number of 2's multiplied together. So these would divide out, and I would end up with 1, 2 left on the top. So on top, I now have 2 and n to the n power. On the bottom, I want you to think about this. If you expanded this out, said n plus 1 to the n plus first power, think about expanding things. Think about like x plus 1 squared. Well, that's x squared plus 2x plus 1. The first term is just x squared. If you have x plus 1 cubed, that's x cubed plus blah, blah. It's 3x squared, 3x and 1, but the first term is x cubed. If you have x plus 1 to the 8th, the first term is going to be x to the 8th power, and then it'll go on from there. So when you have n plus 1 raised to the n plus first power, your first term will be n raised to this power. So it will be n raised to the n plus first. And then you will have many terms after that, but of course they are all less in terms of power. The highest power is that n plus first power. So as we take the limit, as n goes to infinity of this, you'll see now that we've got an nth power on the top, we've got an n plus first power on the bottom, higher powers on the bottom, so the limit is 0. 0 is less than 1, obviously less than 1, so this converges. Okay. Next, let's look at 2n factorial over 5 to the nth power. Now again, very often we can move this off to the side. We use ratio tests when we see factorials. So again, I'm going to set this up. I'm going to have the original term on the bottom, 2n factorial over 5 to the n. Up here, I'm going to have 5 to the n plus 1. This is a little bit tricky now. You're going to have 2 times n plus 1 factorial. Okay, so 2 times n plus 1. So maybe I'll do a little bit of simplifying on this even before I move this up. Maybe I'll do it all kind of at once. So I'm going to, on this piece, this would be 2n plus 2 factorial over 5 to the n plus 1. Let me multiply by the reciprocal. Like that. Take the limit as n approaches infinity. Okay. 5 to the n divided by 5 to the n plus 1, we'll end up with a 5 on the bottom. Now, here, this 2n factorial and 2n plus 2, there's going to be a cancellation here. I want you to think about if you actually wrote 2n plus 2 factorial out, you'd have 2n plus 2 plus the number right below it, plus the number below that, plus the number below that, and so on. And on the bottom you have 2n factorial. Well, that's 2n, and the number below it and the number below it, and so on, these things will divide out, and we're going to be left with this. So what we're left with, if we can move this out, is 2n plus 2 times 2n plus 1. I don't have a lot of room here, so 2n plus 2 times 2n plus 1 over 5. Well, 2n plus, all the power's on top. There's no power on the bottom. So the limit is infinity. Obviously bigger than 1, so this diverges. And here we've just got a little review. First of all, an integral. If I raise the power, raise it by 1, it becomes 5/3. Divide by the power, 3/5. Plug in 8, plug in 0. 8 to the 5/3, you could write that. You could just say it's 8 5/3. Of course, 0 to anything is 0. So 8 to the 5/3 is the same as 8 to the 5th and the cube root of that, or it's the cube root of 8, which is 2, and 2 to the 5th, which is 32. So it's 3/5 multiplied by 32, which is 96/5. Okay. A graph of f consists of two line segments and a semicircle. What is the value? Well, we need to find the area, because of course an integral finds area. Okay. So finding the area, well, this is a triangle, base of 2, height of 1, so half base times height, the area is 1. Now notice it is negative, so we'll have to account for that. Here we've got a circle, of course pi r squared, but this will be divided by 2 because it's only a semicircle. So pi times, and the radius is 1, pi times 1 squared divided by 2 is just pi over 2. But it's all below the axis, so we've got negative 1 and minus pi over 2, and that is the total area from negative 2 to 2.